we're looking at something called as net force if not resultant force. I will explain this with an example. So we have a car. I'll represent all of this with FBD, free body diagram. It is experiencing four forces as of now. One is the person pulling. Second one is the gravity pulling it down. The normal force pushing it up. And the frictional force pulling it to the left. Now, end of it, the car moves only in one direction. That is, say, to the right. That is, in place of all of this, I can replace it with a single force because everything moves in the single direction, right? It won't move in all the possible direction. Whatever the force is acting, not in all the possible direction, things move. It will move in a direction which is the resultant force, if not net force. So that's what net force means. That is, it is the single force that will replace all of it. Here we have the definition. The net force is the vector sum of all the forces that acts upon an object. It is the single force that has the same effect as two or more forces, right? So in place of two or any number of forces, you will replace it with a single force that is known as net force. So the example, the simplest version of vector sum is this, right? All of this. You will not have complicated versions. You will have just simple version. Force in a single line. So you'll have forces which are in single line. If they are in same line, the rule is that we need to add them. If they are opposite direction, same line and in the same direction, add them. Same line in opposite direction, subtract them. That's all. Very simple rule. Okay. So I have decided on the scale being this. This long force would exert 5 Newton force on a given object. So if there are two forces that are acting in the same direction, as you can see, both are almost the same length. I meant it to be of same length. So if two forces are acting to the right, then I'll take it as what? Addition of those two things, and in this case it will be 10 Newton. If we have 5 Newton and in the opposite direction 5 Newton, well, what will happen? Is it 10 Newton? No, right? It will be 0 Newton. How did I get 0? How is that we're getting 0? We have 2 of it because this is negative 5 Newton. So we have to decide on what you will take it as positive and what kind of force you will take it as negative. I generally go with right and up is positive. So since this is left, it will be negative. The length will indicate how much force there it's acting over there, and the direction indicates it's indicated with a negative or positive sign. And when it comes to representing with a number, like for here, this is the length is double whatever is over here, the scale. So this would be 10 Newton, right? Oh yeah, by the way, this we need to represent with the single long line. This is nothing but your 10 Newton. And this is 5 Newton. And as a whole, this would be 15 Newton to the right. While this would be minus 10 Newton and this would be 5 Newton and this would be negative 5 Newton to the left. And over here, since this is down, opposite to my convention, this is around like say minus 10 Newton and this looks around plus 75 Newton. As a whole, we have minus 2.5 Newton downwards, right? And then we have one more set of example, a free body diagram wherein we see 300 Newton to the right and 200 Newton to the left. So I'm taking right and up as positive. The net force over here is 300 minus 200, that is 100 Newton to left. And over here, the net force would be equal to 0 Newton. It's neither going up or down, is it not? So it's just 0 Newton. Oh, sorry, this is to the right. My bad. So this is about your net force. We're going to use this, a simplest version of net force. But important thing is this part. I'm sure you guys knew about adding and subtracting forces. But this is something that we need to understand. Taking things as positive and negative and being clear with what is positive and what is negative. So pause and have a look.